atoms are composed of protons, neutrons, and electrons. Now, the number of protons in an atom determines what element it is. But we can have the same element, but with different masses. These are called isotopes, and these are determined by the number of neutrons in the atom. For instance, lithium has two different isotopes, lithium-6 and lithium-7. Lithium-6, which we often show as lithium with a 6 up here, this 6 being the mass number. Lithium-6 has three protons and 3 neutrons in the nucleus. Lithium-7 has 3 protons and 4 neutrons in the nucleus. They both have 3 protons, and that's because lithium always has 3 protons. We can see that on the periodic table. But we can have either 3 neutrons or 4 neutrons, and these are the two different types of isotopes. Now, these two types of lithium have different masses and different natural abundances. So, for instance, lithium-6 has a mass of 6.0151 AMUs. This is 9.99 times 10 to the minus 24 grams, so a very small amount. And that's why we use AMUs, because they're just easier to work with. Now, the natural abundance, that's if you go into nature and you found all the lithium in the world, 7.59% of that would be lithium-6. The rest of it, 92.41%, would be lithium-7, which has a slightly higher mass. What this means is, if I take a chunk of lithium and I could look at each individual atom, the majority would be lithium-7, and there'd be a small part that would be lithium-6. Now, if we look at the periodic table, we'll see here this is the atomic number, but we'll also see another number. That is the mass, or the average mass of lithium. And notice that that is 6.94. Well, that's because some of it is composed of the lithium-6 and some composed of the lithium-7. So let's look at how we determine that average atomic mass. That average atomic mass is found by taking the sum of the isotope masses times their fractional abundances. All right, so lithium has two isotopes, lithium-6 and lithium-7. We have both their masses and both of their abundances. By the way, notice that the two abundances, if I added these together, they would equal 100%. All of our lithium in the world is composed of either lithium-6 or lithium-7. All right, so what does this sum mean? Well, this means that I have two isotopes. So for isotope 1, I take the mass times its abundance, and then for isotope 2, I take its mass times its abundance. Now notice the abundances we use are going to be the fractional abundances. Now we have percent abundances here, so to get to the fractional, I take the percent and I divide by 100. So that'll be 0.0759 for lithium-6, and it will be 92.41 divided by 100, or 0.9241 for the lithium-7. And so now I take the masses, isotope 1, the mass times the fractional abundance, and the mass of isotope 2 times its abundance, and I get 6.4835 AMU and 0.4565 AMUs. I add those up and I get 6.94 AMUs. That's what I see on the periodic table. That is the average atomic mass. Now notice one thing. That's 6.94 AMUs. That's somewhere between the mass of the lighter of the two isotopes and the mass of the heavier of the two isotopes. That makes sense. You couldn't say that, hey, I have one isotope that's 6 AMUs, one that's 7 AMUs, and somehow the average is 28 AMUs. That just wouldn't make sense. Let's look at this if, let's say, we had silicon, which has 3 isotopes. It has silicon 28, 29, and then 30. Silicon 28 is the one that's the majority, but notice if we added up these 3 different abundances, we'd still get 100%. Well, in this case, seeing that we have 3 different isotopes, our average atomic mass is just going to be the mass of that first isotope times the abundance of that first isotope plus the mass of the second isotope times the abundance of that second isotope. And then do the same thing for the third isotope. And we just do this. We add up all those multiplications, and we get the average atomic mass. If we had something that had 4 isotopes, we then would have a fourth mass times abundance.